Hi, everybody. Today, I want to start to talk about artificial intelligence, AI, which is, all in the news. Everyone's chattering about it these days, probably specifically because of the recent rollouts of ChatGPT, DALL-E, Google Bard, GitHub Copilot, and frankly, a bunch of other public AI showcase services, which I think are giving folks the impression that AI has sort of suddenly moved forward. But in fact, the advancements in the field have been happening over years and in fact decades and brought us to this point, but it's very visible right at the moment. So what I want to do today is start to share some of my perspectives on how I think about AI, what it is, what it isn't, how it works at a very high, simple, super conceptual level, not nuts and bolts, nothing technical. And my goal here is really to try to give some intuition about AI, especially for those of you who are curious but not super familiar with how it works. A subset of AI is called machine learning, or ML. But in fact, the term machine learning really describes pretty well what AI in practice is today, which is learning and regurgitating in interesting, valuable, and potentially unexpected ways. And we'll talk about that in future videos. So you'll see the terms AI and ML used fairly interchangeably in practice, and a lot of folks just say AI, ML. Now, AI is a model, and it's important to remember the old adage that all models are wrong, some are useful. And some of these AI models today are extremely useful and getting very powerful. Now, what AI models fundamentally is the statistical relationship between inputs and outputs. That's it. Now, what kind of inputs and outputs? Well, really, it could be anything. It could be math formulas, could be motions of the planets, reaction of ice to changes in temperature. But AI is frequently used and probably most useful where the relationship between the inputs and the outputs is not just a given formula that can be calculated, but rather where those relationships are less obvious or not obvious at all. And they might be a bit squishy, but still fairly consistent overall. And so for this reason, AI is frequently used to model things related to human behavior, things that we'd use our intelligence for, which are likely to be a bit squishy, but still fairly consistent and predictable. And this context of modeling human behavior is probably the most honest use of the term artificial intelligence, in my humble opinion. Now, these AI models work by taking in a set of inputs and then predicting an output. Now, the range of squishier things that AI is used to predict is, of course, huge and expanding all the time, as we all see every day. Includes, some random examples like predicting the price of a house, given the characteristics of the house, the neighborhood, the overall housing market, et cetera. Predicting movies that I might want to see, given the characteristics of movies I've enjoyed in the past. Predicting whether a given image contains a cat, or predicting an image from the input phrase, gray cat on a fence in a field, or predicting the next word in a sentence, given the sentence so far and the topic the sentence is meant to be about, or predicting an entire sentence in English, given an input sentence in Swahili, for example. You get the idea. It goes on and on and on. Now, I use the word predicting because the model's not calculating the output. It is looking at all the data it's been trained on and then making a claim about what the output is likely to be given the training data it has seen in the past and the patterns, those statistical relationships that relate inputs to outputs that it has gleaned from all that learning it's done. And that's why we use the term machine learning. And I'll talk a little bit more about what's involved in that learning process next time. So thanks, everybody. That's my quick thought for today. I'll be back soon with more. Thanks.